Hi, my name is Andrey Lebrov. I'm a founder of a small production house called LMI here in the UK. We specialize on large-scale CG productions for venues such as museums and theme parks, as well as commercials and film and TV shows. Large-scale production pipelines imply the use of software such as Katana, Clarissa FX, or Houdini Solaris. And also, since not that long ago, Octane standalone is one of the possible assembly scenarios, which makes me really excited, because that brings unprecedented rendering speed to our creations. To be able to effectively manage hundreds or thousands of variants of the assets, we need to follow certain principles in production. Once in the pipeline, we start compounding the libraries of assets. People, clouds, trees, flora, animals, any kind of set dressing elements that can be used in world building. Today I would like to talk about Gaussian splats, why the interest is growing, what's so special about Gaussian splats, and why it's a first step towards the real future of large-scale production. I bet you already heard something about Gaussian splats, one way or another. It's worth talking about the benefits and why interest is growing. Gaussian splats are lightweight. Maybe not in size, but in render times. They render instantly. They respond to light. Capturing splats is relatively easy, and not only singular objects, but whole locations. And finally, undeniable benefit of Gaussian splats is the fact they interact with 3D objects in reflections and refractions. And with engines such as Octane render engine, you can seamlessly and effortlessly relight Gaussian splats. So it slowly but steadily becomes sort of replacement of traditional primitives. I started to be interested in Gaussian splats personally about a year ago, so my learning path with splats was kind of funny. I wanted to capture big trees straight away. And it so happens that for the past few years, I'm steadily developing my skills as pipeline and FXTD, which proven to be very handy with Gaussian splat. For big objects acquisition, obviously we need a drone. So I started to experiment with drones by manually flying around the trees. If you know anything about Gaussian splats, they love continuity. And manual drone operation around the tree is choppy. So I went ahead and developed a Houdini tool that allowed me to pre-plan the flights and then automatically deploy them on location. What sets this approach apart from others is I'm utilizing satellite LiDAR data, and I have full elevation of the trees and all the objects on the terrain, so I know exactly how high the tree is and where I need to fly to get the best coverage possible. Moreover, as this tool is for creators by creators, it doesn't cost thousands of dollars like some industrial solutions for DJI drones. So the tool allowed me not only fly really quickly and precisely around the trees, but repeat the missions across the seasons. Now we're able to capture whatever we want with the precision of a robot and repeat it in any season we want. Essentially, we can build really efficient, beautiful looking libraries of assets of real objects, real-world objects. And since we are specializing in large-scale environments, you already see how it's beneficial for our pipeline. But before I dive into this exciting part, let me tell you about other experiments we commenced with Gaussian splats. Apart from large-scale Gaussian splats acquisition, I was interested in how we can acquire sharper splats, because, you know, it's common to see blurry splats and smeary shiny surfaces. So that was the challenge that I also wanted to overcome. And a couple of months ago, I shared a big video on my YouTube channel where I explained how exactly I approach the capture of shiny objects and turning them into Gaussian splats. When capturing a Gaussian splats, the coverage is really essential, and I'm showing precisely how I'm doing it to achieve sharp results with various electronics if I need it for commercial. And this approach produces results sharp enough to be used in real commercial production work. How would that work? For example, often when working on a commercial, you receive CAD data from the client, the model from which something is made. Like, I don't know, if I'm doing a commercial for BenQ, I would receive a CAD model of this object and I would be able to fully replicate it in 3D. But I also can capture it as a Gaussian splat because it renders lightning fast, and Gaussian splat would look realistic out of the bat, unlike 3D model that would require a lot of post work. With this Gaussian splat and with the CAD model, I would be able to do fancy X-ray effects or line traces, motion graphics with the Gaussian splat. That video I posted on YouTube, it's quite extensive and quite long, so I wouldn't even try to fit it into this presentation, but if you're interested, please go ahead and watch all the details in my video. Getting back to foliage acquisition, one short trick I can share with you right now is that shiny object does not require tons of splats. They require more precise training, whereas foliage, like trees, they require tons of splats because it's myriad more splats required to represent all the details. Plus, drone footage is suboptimal optical capturing tool. As such, during training, it introduces certain degree of degradation to the training. So we can see various hue shifts, chroma, mutations, ghosting, especially under the branches, because it's impossible to have the tree standing still, which Gaussian splats require. Inevitably, branches will swing on the wind, and some portions of your Gaussian splats will inevitably have sky color baked into the branches. To deal with that, I developed a set of surgery tools for splats, I call it. It's called LMI Splats, and it allows me to edit splats, color grade them, restore them, fix them, and make them decent enough quality to again be used in production. These tools allow me to go into harmonics. I can amend spherical harmonics altogether or per band. We have Splats Viewer, specifically designed for Houdini's viewport, and we can view what we're editing on a live splat, both on Windows and on Mac. We can efficiently remove outlier splats, artifacts, target specific hues, and finally, we can efficiently deform splats. There's another set of tools I made to derive the skeleton of the splats, and trees are a perfect subject for that. It's a really natural process of tracing the growth of the tree, and then we can cluster branches together and have a really organic looking wind movement on Gaussian splats on a real acquired tree. I cannot help myself but being really excited about that fact. I already mentioned we're using Octane render engine for its spectral nature, its realism out of the box, plus it's the only leading engine that allows you to properly relight the splats and cast shadows from splats. Moreover, for the past few years, we've been working at shrinking the gap between large-scale production and GPU render engines. It turned out Octane standalone is a perfect platform for such projects. The thing is, Octane standalone was meant as an assembler at first, by design, but due to certain historical factors, it was not developed in that direction. So now we're generating interest of community by developing certain tools that enable seamless work in assembly pipeline and Octane render engine. Our primary software is Houdini, and we do not render in Houdini anymore. Instead, we decoupled rendering from Houdini completely and assemble our scenes in Octane standalone. With a few clicks, we can export complex scatter systems into Octane standalone alongside with any assets, any Megascan collection. The process is really seamless, and I encourage you to find out more on my website, Lebrov.com. And I did mention that Gaussian splats are the first step towards real future of production. The thing is, Gaussian splats, unlike nerves, are easier to train, but they are simpler neural representation of a neural object. But as technologies, as softwares and algorithms and logics are moving forward, neural rendering is not that far away. For example, Octane Render Engine just announced their neural rendering in version 2027 alpha. Nerves didn't gain such crazy popularity as Gaussian splats because they were crazy resource demanding and hard to train, but at the same time they were superior neural representation. So now you can see where the progress is going, and it's not AI prompting. AI prompting generation is one paradigm that was born, and it's not going anywhere, but the real production will stay the same. It will just morph into another shape. With our pipeline, we already can assemble worlds with real-looking, absolutely fantastic assets. Coupled with Octane's new neural rendering, that's the future. Soon we will be able to train next version of Gaussian splats, neural objects. We will be able to generate those neural objects. We will be able to enhance, manipulate existing splats. And true neural objects will know how to interact with light. We will be able to reshade them, and it will be a simple representation of objects in scene. So in my humble opinion, whatever made you to watch this presentation today, it's a great interest to have. And I encourage you to explore more. It's a really interesting topic, and Gaussian splats, honestly, are really easy to acquire and start having fun with them. If not for production, it's a great way of capturing memories. I don't know, a flat you live in, a house you live in, or the places you loved as a child. I have various objects scanned, toys of my kids, a bench in the park we loved to sit on. With hardware such as Apple Vision, I can relive that moment in the absolutely new dimension. Soon we will see various hardware supporting holograms, and you know, Star Trek is here. I hope you enjoyed that presentation and I've been able to teach you something new or spark interest in exploring more. If you're interested either in Gaussian splats, how to acquire the quality we acquire, or in the pipeline, Octane assembly pipeline, please visit my website or my YouTube channel, Andrey Lebrov. Thank you for your time and have a great rest of your day.